right, guys, if there's no questions on the homework, well, we're going to look at determinants. Yes. Huh. Yes. Multiplication. Which one are you, or what problem number?
Is that impossible, or can you just...
Yeah, that's impossible.
Okay.
Because when we look at this here, and we'll look negative 8, 4 plus 12, 2. So if we look at this one here, if we went on and tried to add the two matrices together, well, we would have 9 plus 12 for the first two, because they are matching. And next one, negative 8 plus 2, and then we would have 4 plus, well, 0 is an actual element inside of a matrix, because we can have the 0 matrix, which is all zeros, yes? Well, do we have something here to add to it? We can't just put 0, because 0 is an actual element, so there's nothing there, right? Because if we're adding or subtracting, we need something to be there. And since there's nothing there, we can't actually add them together. No, because there has to be something there. For two matrices to be able to be added or subtracted, the dimensions have to be the exact same. Because there has to be something that attaches those two together. Does that kind of make sense? Yeah, because we can't just leave the 4 plus just by itself. There has to be something that goes with it. Now, what we're looking at today is discriminants in Cramer's rule. Now, we're skipping 4.4 because really that's just talking about transformations of functions or shapes. Because when we talked about in geometry, where we went about moving a shape up, down, left, right, dilations, increasing, decreasing, we could actually represent them by matrices. And we can do those with matrices themselves. Because for a square, we could talk about the vertices of a square being the 4 spots. So if we had a square, locations of A, B, C, D in a coordinate plane, we can actually write it as A, B, C, D for the x values, and then we can do 1 for the y values. And if we wanted to scale it, well, we can dilate it by 5. Okay, well, we're multiplying all those units by 5. Or we can do it like this here to represent the values. But I'm not too focused on that there. But what we're looking at next is kind of determinants. The value of a second order determinant is the difference of the product of the two diagonals of. So the two ways we can write determinants is DET, our brackets, and the matrix inside. The other way is that instead of having brackets, we just have two almost looks like absolute value bars. It's telling us that we're taking the determinant of that matrix. Now our two diagonals, the hider, well, AB would be 1 and BC would be the other. The ones going from left to right are going to be positive. The ones going from right to left are going to be subtracted. So look at our first example here. So the numbers going from left to right would be 5 times 9. And that's the only one. And we're going to subtract from it. Negative 4 times Well, what is 5 times 9? Minus. Negative 4 times 8 is? Well, the negative would make a. So 45 plus 32 is? So the determinant of this is? Now, we can plug this into the calculator. But this here, there really is no need to do a second order determinant in a calculator. Because I really feel like the time it's going to take you to plug in the matrices, pull up determinant, take determinant matrix A, we could have done this by hand 2 times over, at least. So doing these here are not really a big thing. Now, one of the other things with determinants is they have to be a square matrix. It has to be a square matrix for us to be able to take the determinant. Well, that means we can have second order, but what would a third order be? It would be a 3 by 3, 3 rows, 3 columns. Fourth order would be 4 by 4. And those, especially a 4 by 4, I would do it in the calculator. It is possible to do it by hand, but the calculation starts getting bigger and bigger. But let's stick with second order for now. So here we would do what? Times negative 11, well, it really doesn't matter. Minus. And at this point here, we could type the whole thing into the calculator or say that, well, that's 0. 6 times 4 is? It's in the same negative. Second order determinants are really, we don't have to do it in the calculator, we can do this by hand. So for 1A, what would we be doing? Minus negative 6 times 8 would be negative 70, which would be the same as plus 70. Now, if you were doing this in your head, it would be 22, yes? Now, we know that these are going to be subtracted, yes? How can we go about doing this in our head if subtracting? Yeah. Yep. The reason I'm bringing this up is because just for counting money if you ever have to, and I do this with grading also, the easiest way to go to do this is to go from 48 up, because I know that they're going to be the difference, yes? So if I look at the 8, and I'm going to go to the next 0, so how many do I need to add to 8 to get to 0? 2, yes? Which makes that 4 into A. What do I need to do to 5 to get to 7? So it would be positive 22 because the 70 was bigger. That's it. Does that make that a little bit easier to work with? And when I calculate your grade, when I'm doing the grades on the test, I'll count up how many of you've missed and do that exact same thing to actually get what it is out of, or what it is out of the total. It makes it a little bit easier, at least I think. Let's look at the next one. What we'd have, 7 times negative 4 minus what? Negative 4 would be negative 28 minus 45. They're going to be added together, so we'll get a bigger negative. 5 and 8, that'd be 3 carry the 1. 5, 6. Negative 73. Questions on this here? The diagonal rule, rewrite the 2 columns. Let's actually just look at this here. So this here is our third order one because it's a 3 by 3. Now we're doing the same thing because on the first one we took the diagonal from the left to the right and subtracted it from the right to the left. Well, if I do that here, well, get a highlighter. because I would have this diagonal, yes? Then I would have, well, this, because I need to come all the way back around, and then I have this set up here, yes? That's can be a little bit difficult to keep track of the straight lines, yes? So what we suggest, and what we suggest do, -3, 4, -8, 2, 5, 3, 6, 9. I'm going to rewrite the first two. Next to it. I'm going to write the first two columns next to it. Because now, like I did at the beginning where I had to wrap it around, now we can actually go straight down. We don't have to worry about trying to come back, have -8, 6, and -4 come back around. So now when we look at our diagonals going from the left to the right, we have that nice one. We have this nice one, and we have this nice one here. We have three nice diagonals coming across. Now, we could do this all at once. I don't advise it. But our first diagonal is going to be times 2 times 9. Our next -8, -4. And our last one is -3 and 5. So these are all the diagonals going from the left to the right, yes? Now we said on the first one, well, we took all the diagonals going from left to right and subtracted from it the ones going from the right to the left. So okay, let's go on and calculate these up first, and then we'll look at the other ones. That way we're not having too much up here all at once. Well, the first one we have is 4 times 2, which is, times 9 is, well, how many negatives do I have in the second one? So a negative times a negative is a, let's not even worry about them, because they're going to cancel out. So we could do 8 times 6 times 4, 4 times 8 times 6, any of these orders. Let's do 8 times 6. 48, yes? And then we'd have 48 times 4. Well, 48 plus 48 is 96. 96 and 96 would be 192. Yeah, because 48, well, we're multiplying by 4, adding it to itself 4 times. 48 and 48 would be 8 and 8 is 6, carry the 1. 4 and 4 is 8 plus 1 is 9. 96 and 96 should give us 192. And the last one, 3 times -3 times 5, well, that's going to be negative. We would add all these up. Because this would be the value of the diagonals going from the left to the right. Well, because on our 2, the ones we did before, we took the ones going from the left and right and subtracted the ones going from the right to the, so that means, well, highlighter. Well, we're going to have the 3. So we would have -8 times -3 times 9. 4 times 6 times 5. And 3 times 2 times -4. Because these are the 3 going the other direction. So the first 8, -8 times -3 times 9 will be positive. 8 times 3, well, Any way we do is what? 216. That's going to be a little challenging no matter how we slice it. 6 times 5 is 30. Times 4 is, and the last one, 3 times negative 4 is, and we'll add these 3 together. Now, in the first one, the 2 by 2, well, we subtracted the ones from, we took the ones that are going from the left and to the right and subtracted from it the ones going from the right to the, so, well, that means we're going to take 219 and subtract from it 312, which will give us 90 what? And that's the determinant of this 3 by 3. Would it be faster to do the 3 by 3 by hand or in the calculator? Because I will say that what we did here, because we did break it out and stepped it down, so it took a little bit longer. But if we look at the calculator, let's look at 2a. Well, to do 2a, the first thing we'll do is second matrix, go over to edit, and we would have a 3 by 3. X to the negative 1. Now we would have negative 5, 9, 4, negative 2, negative 1, 5, negative 4, 6, 2. So we type the matrix in. We good with that part there? Now we'll go second quit. So we're wanting to take what? The determinant, yes? So we're going to go second matrix. And we're wanting to do some type of math operation, yes? This first one. So we're going to take the determinant of second matrix A, negative 48. And that's it. Questions on this here? Figured it out, Paris? DE, so second matrix over 1. To math. So like when you go to the one in the middle is math, and that's where we do most of the calculations. And that's it. That's all we have to do for this here. Now, we're going to stop there because the second part is still dealing with determinants. But we're talking about Cramer's rule. And what Cramer's rule is, and what it deals with, if I can get the right screen, is actually solving a system of equations. And using determinants to solve it. And what we'll see tomorrow is really that by Cramer's rule, the value of x is going to equal the determinant of 14, 27, 3, negative 8 over the determinant of 2, 9, 3, negative x. And we'll see how this is set up, but this will give us the value of x for the system of equations. We can solve it by using this. So your homework is this here, 3 through 12 all. Now, normally I would pass out a green textbook and have y'all mess with that. But I'm going to give you a working instead.